Hey everybody, so we're back and we're looking at our graphic organizer again. So pull it out so we can finish it. If you don't have it, go ahead and push pause on the video and unpause when you come back. So we're gonna finish filling out this graphic organizer. So remember, this is being used for factoring polynomials. And remember that factoring is taking something that's big and breaking it down into 2 or 3 manageable pieces. Okay, so we're making things smaller into pieces that are easy to use. And as always, we always look for that, what's going on? We always look for the GCF first, okay? Once we look for the GCF, then we count the number of terms. So we're looking in this column today. And today we're gonna look at what happens when we have a trinomial where a equals 1, or excuse me, not a 1, basically. Anything else in front of the a where it's not equal to a 1. Okay, so for example, if, I'm going to get a little bit closer on here. So let's say, for example, we had ax squared plus bx plus c. We're looking for this value of a where a is basically not equal to 1, and not even just greater than, but it could be less than, it could be a fraction, it could be a negative, where a is not equal to 1. And here's how we would do that. Oh, almost forgot. This is a c. The way that we deal with this is what we call x grouping. Okay, and that's the process. The one that we used for the other 3 term was called x factoring. Here, we're going to use something called x grouping, where we basically take a big X, okay, and we're going to take our value of a times c, so we put our value for a times c here, and we put our value for b here. And then we take whatever number's there, we take the factors of that number, and we have to find 2 numbers that are going to multiply to the value here, and we'll add to the value of b, okay? Once we do that, we'll break apart our original function and group them. So let me show you what I'm talking about. So we're looking at this right here. We know this is a, b, and c. We always look for greatest common factors. I don't see anything that I can pull out of 2x squared, 9x, and negative 35. So there's no greatest common factor. But now let's count our 1, 2, 3 terms. And our a value is 2. And so we can't use this side of the branch. We have to use this one because it's not equal to 1. So we know our process is going to be x grouping. All right. So x grouping means we're going to take a big X and we're going to put our a times c value here. So a is 2 and c is negative 35. So a times c equals 2 times negative 35, which is negative 70. So that's what I'm going to put here. And then our b term is right here is negative 9. So we put that at the bottom. And so now that our x is set up just like in our other form that we were using, the x factor form, we still look for the numbers that will multiply to this number and add to negative 9. So we're still going to make our list of factors for this top number, which is 70. So we've got 70 and 1. Actually, I like to do it the other way. 1 and 70, 2 and 35. And so remember, we're looking for values that will make a 9, right? What else? We can't divide by 3. We can't divide by 4. We can divide by 5, where we get 5 and 14. And look, I think that will work for us. So if I put a 5 here and a 14 here, I know I need it to multiply by a negative, so I know one of them is going to have to be a negative. So now I look here. Because this negative 9 is a negative, we're going to make our bigger value the negative value. And now we're going to double check it. 5 times negative 14 is negative 70, and 5 times negative or plus negative 14 is negative 9. So that's perfect. Now, this is where it's different than the other way. With these middle terms, 5 and negative 14, I'm going to split up this negative x term, and I'm going to rewrite it as 5x minus 14x. So we use these two numbers, and we're splitting up the negative 9 and writing terms that are equivalent. So negative 9x is equivalent to 5x minus 14x. And then we're going to bring down the other stuff that we have. Okay, so now instead of 3 terms, we've expanded it, and there are 4 terms. So now here's where, so we just did the x. Now is where the grouping comes in. So now that we have those 4 terms, I'm going to go ahead and group them, the first 2 together. I'm going to put a plus right here because adding a negative is the same thing as minus. So we're just going to put a plus there just because it will help us to keep this easy to factor. And then we're going to put a parentheses over the last 2 parts. Okay, so now that we have this, we're going to take a GCF out of each of these separately. So we're going to take a GCF out of this part, and we're going to take a GCF out of this part. So now watch this. Out of GCF, out of both of these, they both have an x. So I'm pulling out the x, and I'm left with 2x squared divided by x is just 2x. Bring down the plus. 5x divided by x is just 5. Okay. I'm going to bring down the plus sign here, and now I'm going to pull out the GCF for this. So I know negative 14x and negative 35, I can pull out both of them, have a negative 7. And that leaves me with negative 14x divided by negative 7 is just 2x, and negative 7 divided into negative 35 is a positive 5. Now here's the thing. If I did this right, these 2 parentheses should be the same, and they are. If they're not for you when you do your grouping, you probably made a mistake. So now that we have those 2 groups that are identical, we're going to take a GCF of them, and we're going to pull them out, okay? And then we're going to replace it with what's left. So inside here we go x, and then either plus a minus 7 or just a minus 7. And that is our factor for 3 terms where the a does not equal 1. That's called x grouping. Okay, so looking at that now, if I were to factor this trinomial here, 5x squared minus 17x plus 7, we're going to need to look at our graphic organizer. The very first thing we look at is, do we have a GCF? We don't have a GCF here. They don't have anything in common. So then we look at our number of terms to decide how we're going to factor this. There are 3 monomials or 3 terms. Once we know there's 3 terms, we look at the value of a. So we know this value of a is not 1. It's 5. So we look on that side of our graphic organizer and we read it and we know, okay, I'm going to have to do the X group method. So I'm going to come over here. I'm going to write my big X. And we remember that this is our A times C value. So here's A and here's C. So 5 times 6 is 30. And then we put our B value down here, which is negative 17. So what will multiply to 30 that will add to a negative 17? So let's write our list of factors. So we know that there's 1 and 30, 2 and 15, 3 and 10, 5 and 6. But we know if I'm trying to get to a negative 17, I know 2 and 15 can make a 17. We know that 30 is positive and 2 times 15 is 30, but 2 plus 15 is not a negative 17. So we have to adjust those signs. So we know negative times negative is a positive here, that works. And negative 2 and negative 15 equals negative 17 here. Okay, so now this is where the grouping comes in. We have to make this negative 17x is going to split up into a minus 2x and a minus 15x. Those are just the numbers that we found that are going to make our factoring doable, okay? It's the same value as negative 17x, but now we're splitting it up so we can actually factor. Bring down this part, and we're going to bring down this part as well. And now we're going to group these 4 factors, okay? So now we're going to come in through here with, let's do green. We're going to factor the first two terms, make a plus sign here because we don't want to mess up a negative, okay, which doesn't change the value. And now we're going to pull out a GCF. So we pull out an x, and we get 5x minus 2. Bring down the plus, and we can pull out a, let's pull out a negative 3, because we want it to be the same inside the parentheses. So if I go negative 15x divided by negative 3, we get positive 5x. And if I get positive 6 divided by negative 3, we get a minus 2. So what's left is, what's beautiful, we have this 5x minus 2 in the parentheses here, and another 5x minus 2. That means we did our job correctly. So now we're going to GCF that whole thing out, the 5x minus 2, because they are now the greatest common factor of each part. And we're going to be left with this x and then minus 3, and we're going to put that here. X minus 3, and there's our factor. Okay. So now let's see. Okay, let's remember, using our graphic organizer, we're going to be factoring this example number 3. So for this part A, we're going to look at our graphic organizer. We know we always pull out a GCF. So remember, we always pull out a GCF first. Is there a GCF here? 9 and 64 don't have anything in common as far as factors go, so we move on and we count the number of terms. The number of terms we have are 2. Now, the only way that we could possibly factor out 2 terms if it was DOTS dots, or difference of 2 squares. So we are going to check it. We have a minus in the middle, and then we know 9 and x squared are both perfect squares, and so is 64. So that's good news, and we're going to plug that in to our cute little factors here. One's going to be a plus, one's a minus. That's part of the dots. And the square root of 9 is 3, so we put a 3 and 3 here. The square root of x squared is just x. And then we're going to do our 64. Square root of 64 is 8, and we put them here and here, and now we're done. Okay, that was for this one. Now, let's look at factoring this next one, where we have 1, 2, 3 terms. And let's see if there's, first, remember, we always look for a GCF. And we don't see a GCF here, so we're going to look at the number of terms now. We know there's 3 terms, and the A value right here is 4. So we know we're going to have to use the X grouping. So here's our big X. We put our values for A and C and B here. So A times C is 4 times 25, which is A times C, which is 100. So we're going to put 100 here. And the B value is 20. So remember, we have to multiply to 100 and add to 20. We have to find those two values. So what will multiply 100? So I know 100, or 10 and 10 will multiply to 100 and will add to 20. So we take these numbers, and that's how we split up that middle term. 10y plus 10y is equivalent to 20y. And now we just bring down the 2 parts that are missing. And now there's 4 terms, and we're gonna group them because this is X grouping. And now we look for a GCF. GCF out of 4y squared and 10y, we can pull out a 2y, and we're left with 2y plus 5. Bring down the plus sign, and we can pull out a 5, and we get 2y plus 5 as well. And again, these match, which means we did our job right. So now we're going to pull out that 2y plus 5 as a GCF, and we're left with the 2y and the plus 5. And that is how, ooh, look at that, they're the same. So actually, we're going to simplify that again, and we get 2y plus 5 all squared. Okay, so let's do this kind of factoring. So remember, again, with factoring, we always look for GCF. GCF here and here, we can actually pull out a 5, and we're left with x squared minus 9. Now, when we're left with this, we only factor what's inside the parentheses because we haven't factored the rest of it yet. We did factor out a 5. That's all we have to do. So now we look here. Is there a GCF there? No. How many terms are there? There's 2. And if you look at our graphic organizer for 2 terms, it can only be dots. So let's look to see if there's dots. We've got a difference of 2 squares, so we're good. So we're going to set up our parentheses, one's minus, one's plus. We know x squared becomes, or comes from an x times x, and the square root of 9 is 3 and 3. We're almost done. Bring down your 5 that was out front, and we're done. Okay, how about this next one? If we're going to factor this, we again have to look for our GCF. And so is there a GCF for 6, 14, and 8? There is. We can pull out a 2. And we're left with 3q squared minus 7q plus 4. Now there's 3 terms, and we're going to look at, okay, if there's 3 terms, what's the value of A? So our value of A in this case is 3. So we're going to have to use X grouping. And for this X grouping, we're going to multiply those values of A and C at the top. So remember, this is A, and this is C. 3 times 4 is 12. That goes on top. The middle term here on B goes here. What multiplies to 12 and adds to 7? Well, we know 3 and 4, right? But keep in mind, they both were going to have to be negative because of this negative on the 7. So now let's check it. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7, so we're good. And now we're going to kind of group these by separating this negative 7q into these parts. Negative 3q and negative 4q are equivalent to negative 7q. And now we're going to bring these parts down, bring this part down, and then don't forget that really these are all in a parentheses with a 2 here, so don't forget about that too. And now we're going to do the grouping step. So we go group, group, make a plus there, group, group. So now we're going to look for a GCF in both of these. We can pull out a 3q, and we're left with q minus 1. Bring down the plus. We can pull out a negative 4. And we end up with q minus 1 as well. Again, we want these to match. So now these can be pulled out. We get q minus 1. And then we've got 3q and minus 4. And then don't forget this 2 that was out in front. Don't forget it. It's right there. And that's our factoring. Now our last one that we're going to do is solving quadratic equations, which uses the factoring that we've learned. But then, in addition to solving, we always set it equal to 0 because we're solving. So we set it equal to 0. This one happens to already be set to 0. So now we're going to factor and set the factors equal to 0. So here we go. Again, we don't have a GCF here. We have 3 terms, and our A value is 3. So we know we have to use X grouping. So here's our big X. We put our values for A times C here, which is negative 24, and our B term in the middle. What multiplies to negative 24 and adds to 10? Well, if I was to list it, we've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So the way I see it, there could be 2 choices here. We know that the product is negative, so one or the other has to be negative. So we're going to pick 2 and 12 and see if this will work. We know if they add to each other, 2 and 12 don't add to a 10, so one of them has to be negative. We'll make it the 2, so it can add to a positive 10, and they still multiply to negative 24. So these are the terms that we're going to use to split up the 10x. So we've got negative 2x and positive 12x are equivalent to 10x. And then we're going to bring down our minus 8 and bring down our 3x squared. And now we're going to group the first 2 and last 2 and look for another GCF. GCF for the first group, we can pull out an x and we get 3x minus 2. GCF for the second group, we bring down that plus sign, is 4. So we're going to pull that out and we get 3x minus 2. So again, do these match? Yes, they do. Good thing. We're going to pull those out as a GCF of the whole thing, and we're left with x plus 4. Now, we're not done yet because we're still solving. Here's our equal to 0, so we bring that out, set it equal to 0, and we're going to use our 0 product property, which remember, something times something equals 0 means both of these parts have to equal 0. So this has to equal 0 and this as well. So we say 3x minus 2 equals 0. and x plus 4 equals 0 as well. And then we solve. Add the 2, divide the 3, and we get x equals 2 over 3 as a solution. And we subtract the 4, we get x equals 4. And those are our solutions for solving the quadratic equation. For the next one, I want you to get started. Again, in order to solve, we have to set it equal to 0. We don't have it equal to 0 here, so just move the stuff over so that we can. So we're going to minus the 4p, which cancels it out, and we're going to add a 5. So we're left with a 0 on the right side now, and now we've got 5p squared, a negative 20p, and a positive 20. So now that this is set equal to 0, you can solve by factoring. And I'm going to let you do that on your own because once we all know how to factor and set it equal to 0, so now you can do that.